Okay, so I'm gonna make sure saw that. Great. Okay, well, welcome. And this is our second last session. We have one more now. All of the K to threes are finished because energy was their last unit. And for 4 to 6, we will continue on with one more after this, which is space. So that's going to be a little bit new for the 4, 5, 6 group because we haven't had that. It's always been traditionally just grade 6. So welcome aboard. And I'm going to turn it over to Ted because he's going to take over the whole front part of it.
Hi, Randy. Hi, everybody who will be joining us later. I'd like to begin with, as per usual, our acknowledgement of land and people. But before I read through the one that we have set before us here, I would just like to share a few words that Stephen Paquette, an elder, has mentioned, who's here saying on this video. So if you could share that, please, and we'll just hear what he has to say, and then we'll come back to this.
What I've learned from my elders is that when we do acknowledgement of the land, it's not about acknowledging whose land it belongs to, because that indigenous worldview, we never owned the land. We were simply caretakers of it for future generations. And what I've been taught from my elders is that when we do that acknowledgement of the land, it's much more than just the territory. It's about relationships. It's about our relationships with people that share the land. It's our relationships with Mother Earth. It's our relationships with the four-legged, the finned, the feathered, the crawlers, the original stewards of Mother Earth. It's that relationship that we acknowledge with the trees. It's that acknowledgement that we have with the plant life that is part of the food chain and helps us exist. It gives us our medicines for healing, gives us food for nutrients. It gives us our medicines for ceremonies. We acknowledge water. Water is sacred. Water is life. And what we're told is that when we acknowledge that water, that we always have to acknowledge the carriers of those teachings, which are the woman. So we do that in the same voice. We also acknowledge the infinite wisdom of the grandfathers. Then we take that to the next level, is which acknowledging that relationship that we have with father-son, or in some nations, brother-son. We acknowledge that relationship that we have with Nokomis, Grandma Moon, and how she cleanses Mother Earth. We acknowledge that relationship that we have with our distant relations, the star people. So when we talk about acknowledging the land, it's so much more so than just acknowledging what nation was on that. As we know through all throughout the history of Turtle Island, is that indigenous people were for the most part nomadic people. They shifted. They would move from season to season. It just so happens that Sheridan sits on the treaty territory of the Mississaugas of the Credit, which I'm very proud to always share and educate with people. But in the same breath, I also acknowledge that many, many other nations have walked this territory, and that their ancestors are still here amongst us.
Certainly a lot to digest there, but at the end of the day, it's I find it a really helpful video for me that we often, when we hear the land acknowledgements and we say them, we sometimes it becomes almost a little bit too routine. And if we can just think, as what Stephen Paquette says, think about the relationships we have on this land, the gifts we have on this land, and all those things we have on this land, not just the acknowledgement that there were people here and there still are, but we have special relationships with them, I think is important. So in the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So once again, welcome everyone. This is, as Chris mentioned, I don't know, during the recording or prior, that this is the second last of the sessions. And we hope that as we continue through here, that your confidence with the new curriculum and where you're going with it and how you're going to unpack it is gaining some direction, and that your efficacy, your confidence, and your skill level is growing to unpack this curriculum and present it in a way that is going to be powerful for the kids who will be in your classrooms. The agenda is fairly similar to our other ones, except that we do have an organizing idea. I will spend the time looking at the front end at the cusps specifically, and then how that maybe can quickly impact, or how that might impact our assessment and instructional techniques. I'll try to front load it with information directly related to this organizing idea, so it becomes less maybe repetitive. We do know that some people are piloting just a couple, and some people are piloting all the organizing ideas. So we never know who we have here. And so we do like making sure that this front end is covered. So I will be going quickly, so bear with me. The organizing idea again is energy. This is the first in the only organizing idea in the science curriculum. It has 2 outcomes. Start at grade 5. We can see the 2 there. And the first outcome is focused on energy when it comes in terms of physics, and we're talking about movement and forces and things like that. And the second outcome focuses on energy as a natural resource, and how that where they come from and what they are and how they impact us. An interesting thing, and as Chris mentioned in past presentations, is that this science course is different than ones in the past, where we could teach what was in our little silo or a little course, and then the next teacher taught their course, and so on. When we do take a look at the curriculum closely, we'll see that ideas and concepts and understandings move from grade to grade. So much of what we're going to be covering in grade 5, many of the big ideas were covered in grades earlier, and we could see that the idea of movement and force and pathways began early in kindergarten and all the way through grade 2 and grade 3. In fact, force was introduced in grade 3. When we go to grade 4, grade 3 was talking about more about contact forces, grade 4 non-contact force, and the idea of non-contact forces and how forces affect flight continues on into grade 5. And so we can see that really some of the knowledge and understandings and those skills that we learned from the early grades kind of transfer up the grade. And so that really is where we're at with this course in terms of unpacking it, is that whole sense of transfer. We do think about it. Transfer is what we really want our kids to walk away with. You can go to the next slide, Chris.
I'm just going to add one piece in there,
Sure.
Ted, because some of you may just be starting, and depending on what order you did things in, you will have to be aware too that your students won't have the background for forces in their curriculum. So you don't need to go back and do all of grade 3 and grade 4, but definitely the contact and non-contact, like what it means in some very simple examples. I would go back into the 3-4 folders and grab those before you start sort of planning the energy part for the grade 5, because if you're going to talk about flight, it's pretty hard to have a really good understanding of force if they don't really even understand the basic terminology. So just maybe keep that in the back of your mind. Thanks,
Chris. So if we know that then things do move forward with this course from one grade to the next, the question becomes then what transfers in this curriculum, and how do we teach for transfer? And that's where we're moving towards. So we do know that when it comes to transfer, skills transfer. So you can go to the next slide, Chris. Skills transfer, not only the hard skills like the critical thinking ones, evaluating and so on, but we know that in our classrooms, we also help kids learn and practice and become good at some other those soft skills, such as listening. How do we teach kids to do that? And how can that transfer up the grades? Empathizing, conflict resolution, collaboration is a big one that should continue through all the years. So it's all those things that do transfer as we move forward. Besides skills, concepts transfer. We'll take a closer look at concepts in a bit, but concepts are those things that we can see in both these pictures. The concept of courage is in both of them, perhaps, and maybe we can see independence. And you could probably see other concepts within each of those pictures, because concepts do transfer from one context to the next. And besides concepts, understandings transfer as well. I have 5 understandings there. Each of them on the right-hand side are from the energy organizing ideas for the different grades. And if you read through them later on, we're not going to read through them now, but when you want to look at the slide deck later, you can probably see to those understandings in that context. And then you could probably think of other contexts where those understandings are true. In this particular case, the movement of living and constructed objects in the air, this is for grade 5, is influenced by a set of opposing forces. So perhaps we could see thrust in there, perhaps we could see drag in there, and weight and gravity. So that's the nature of skills, concepts, and understandings. They all transfer. So if we know that all three of those transfer, when we look at our curriculum, we can see where they're situated in the guide. The concepts are included in that knowledge part. The knowledge part also includes rules and other things that perhaps could be in understandings, but they're in there. And we know that flight, for example, and the rules guiding flight are in the knowledge section there. Those transfer the concepts. The facts don't transfer. They kind of just stay. We just know them and they're just stay put. Understandings, again, transfer, and that's how the facts and knowledge fit together. We'll take a closer look at that later. And we do know that the individual skills transfer, not necessarily the entire skills and procedures line. That is pretty much stuck there, but it's the skill itself. If they're comparing and contrasting dog to a cat, comparing and contrasting dog to cat doesn't transfer, but comparing and contrasting does. So let's begin with that knowledge cusp and the concepts within it. Just a reminder, a concept is just an organizing idea of one or two words. You can see the two top photos or images of a book. And it's that a book itself is a concept. And there's something about a book, it has some distinctive added attributes that a magazine doesn't have. And so we can separate those two things, although they are similar. A magazine and a book are different because they do have distinctive attributes. And of course, there are multiple of examples that we can share of books and magazines. And that is the nature of concepts. When it comes to finding them, or one other point I should point out is that the concepts in the curriculum guide and throughout are broad in some cases or specific in some cases. The more broad the concept, the more abstract it is, number one, but that also means we can transfer it from one context to the next. And that also means transferring from one course to another. For example, we can see energy and movement and force in science. We can also explore and transfer and provide context for learning those things in perhaps physical education with our not only with the movement of the human body, but the movement of objects and things in phys ed. And perhaps can that be done in art or drama if you do teach drama or something like that. Concepts also provide a focus. And in this particular case, if we look at this, we can see a multitude of things. But if I say, look at this photo through the lens of Earth systems, we would see a certain thing. If I asked you to look through the lens of human activity, you would probably notice other things that maybe you didn't notice before. And because concepts transfer and provide a focus, that allows us then to hone in on certain things. And that's what I'd like to do, is look at the curriculum through the conceptual lens, first of all, of concepts themselves. That's the next slide, Chris. Thank you. We've done this before in past presentations, but what I'd like you to do is take a quick peek at the learning outcomes this is for the first outcome and some associated cusp lines with it. If you look at it carefully, you'll notice that there are some ideas in there or concepts in there that repeat themselves. And if we highlight all those concepts, which is we'll see on the next slide, we can see that there are a lot of concepts in this curriculum, and it's just the nature of the way it's written. But you also notice that some of those concepts are repetitive, such as force and buoyant force, object. Those kinds of things are repeated. When they do repeat themselves like that, and you'll find them throughout this organizing idea, that gives you an idea that those are the big ones, and they probably will move on into the next grade, and they probably had some mention in previous grades, and that is the case for sure. The words I have in brackets are also concepts Many of our verbs, a lot of the things we do are associated with the concept. So for example, in the skills and processes, if we analyze something, what we actually do is we create an analysis. So an analysis is a certain thing that is different than other things we produce. But we use the process of analyzing to create an analysis. So kids understand what that is. And I'll give an example later. It's helpful then in analyzing when you know what an analysis is at the end. On to the next slide, please. So when we do take a look at all the concepts in both organizing ideas, the ones that jump out and the ones that move on and sort of are the weight of the course are listed there. We've got opposing force and thrust and drag and so on. In the energy resources one, of course, resources and energy resources big, renewable, non-renewable, where those resources are in terms of location and what they do for us in terms of meeting our needs. Those are the big things taken a look at in that particular, in those two outcomes. In the knowledge section, that's where we'll find the definitions. We know that, as I mentioned earlier, concepts all have definitions, and this is where you'll find the definition. Thrust and drag, as you know, is in there if you've taken a look at this curriculum, and it'll be written there. Quite often, though, you'll find words that aren't defined. In this particular case, pitch, roll, and yaw are not defined. There's a link there. It's kind of a little graphic if you do want to take a look at it and see if you want to know what those are. That really helped me out to clarify those three terms as well. So, but the knowledge part does have the definitions of most of the big concepts that we work with. Besides concepts, as I mentioned, concepts have examples, and that word up there should read examples, not concept definitions. There are some, oh, excuse me, I'm still on definitions. That's right, because we've got two outcomes. I just wanted to give you another example from the second outcome. We could see that the term non-renewable resources is defined there, but fossil fuels is not just defined anywhere in the curriculum. So that would be one that we'd have to use our own resources to find an appropriate definition for. So examples are also in there in this particular case. Advanced in technologies, there are none there, but it would be easy for us to find out what some advancements of technology are in terms of humans in flight. But there are examples given of some of the traditional technologies, such as bow and arrow and so on. So that's where the definitions and examples all fall within that right-hand column. Concepts do relate to each other. I've created a concept map for both organizing ideas. This one's quite big, as we know. It looks complicated, but when you sort of keep the colors, you'll know the colors kind of match cuff splines a little bit, and you just follow the arrows and put in the meanings. For example, right off the bat, force has every force has an opposite force. Forces in fluids, which is a liquid or gas, can have we go on the right, can include thrust and drag, and lift and weight, and buoyancy and weight. And then you just follow the lines through, and you'll get a fairly good picture of what the organizing idea looks like if you take a look at that, if you follow the arrows through. It can also help you sort of see where you are in your course as you go along. You might want to refer back to this and say, oh yeah, I've still got to cover this chunk. Cross them off as you go along. And there's another simpler one for the next organizing idea on energy resources. It is a smaller one and a bit more, and so there's not as much to this one. It's not as complicated, that's for sure. So we do take a look at renewable, non-renewable resources, and not only where they're located in Alberta, but around the world. You can go ahead, Chris.
We need to change that to 5.
Oh, you're right. I have grade 4 there, probably on both of them, right?
Yes, I think
Hey, welcome to Art for Kids Hub. This is our YouTube.
they link together anyway. So I mean, it's not a
It's
big
not
deal.
hard to do. I'll make sure to get that done. We can move on.
Okay.
So if we take a look through the curriculum through the lens of understandings, this is where we get sort of the bigger ideas. Understandings are really a logical connection of different concepts. So if we take a look at some of the concepts from our first outcome in this organizing idea, we know that movement, living things, constructed things, air, and opposing forces are some of the key things. Individually, they each have their own meaning, and we could provide examples, we can define movement, and we can find examples of it. We can define living things and find examples of it, and so on. But when we put all those words together in a single sentence, we get a new understanding, so to speak. And depending on how you put those words together, you can create a different understanding. In this particular case, movement of living things and constructed objects in the air are designed to respond to a set of opposing forces, which is different than the second statement. And it's the second statement, go to the next slide, is the statement that shows up in our understanding column in the organizing idea. I have two understandings there. One is in from the first outcome, and the second one is from the second outcome. But you could see how the understanding takes the concepts from the left-hand side, the individual concepts, puts them together to create a broader understanding in the middle column. In the case of some of the understandings in the second outcome, a lot of the concepts maybe in it are not necessarily in the knowledge column, and they're not defined. As Chris and I both pointed out, many of the concepts are covered in previous grades. So if we take a look at the understanding available of energy resources is based on weather patterns and natural features of a location or an area, you'll see that none of those concepts are defined in this particular case. Energy resources would be defined earlier, but not on this cusp line. Weather patterns, well, for that, we'd have to take a look at Earth systems, Earth systems in grade 5. That talks about climate and agriculture and climate, because certainly agriculture and climate, that would be something to be considered when we talk about biomass, for example. When it comes to natural features, we look at the layers of the earth and soil in grade 3. Natural features also include bodies of water, which was taken in grade 2. So again, the understanding from the curriculum perspective that this information, these knowledge and understandings move up the ladder, so not everything is defined. We sometimes have to look backwards. Thanks, Chris, when you move on. And so the understandings themselves are transferable, not just the separate understanding or the separate concepts, but when they're all put into one statement of an understanding, those understandings themselves are also transferable. So we could see the availability of resources is based on weather patterns and features and location of a specific area. Through both of those, we could examine what the area might be. In this particular case, the natural features would be the layers in the ground. And we don't have to play the video, but there's a video there that could be used for something later on. It's just a fascinating little 15-second clip on the thousands of solar panels through this set of shallow mountains in China. It's quite fascinating. But again, the question would be, why are those solar panels located there? What is there about the natural area and the weather patterns that make that an appropriate place for solar panels? Next slide. Oh, that's the solar panel. And again, so with there's another example. This is one for the energy from the first outcome, that the air is influenced by things moving in the air is influenced by a set of opposing forces. Again, that whole thing is true in different contexts as well, whether it's flying a kite or if it's the dandelion seeds flying through the air, the same forces are at play. Very quickly, here's what we've taken a look at, and I just do this just so we don't lose track of where we are. We know that concepts have definitions and examples. They're in the knowledge cusp line. The concepts are transferable, and they're deepened through the grades if we've seen. They do provide a focus, which allows us to have that conceptual lens. And concepts have relationships with other concepts, and they create a broader understanding that can also be transferred. And those understandings are in the center column of the curriculum of the cusps. Next slide, then. We got one more column to look at, and that's the skills and procedures. These are the key skills and procedures when you do take a look at all of the skills and procedure statements in both outcomes. I'm going to deal with both of them at the same time. Investigating, design, Comparing contrast is there, and I included research and collaboration, and I'll talk about why in a second. But Chris, if you can go to the top link where it says link grade 5 energy, yeah, that one. You'll have this copy, so that you'll have this available to you, so you don't have to worry about it. But you can see I've taken the first outcome and I've highlighted the skills and procedure statements. Because when you take a look at the verbs, in everything that is in light blue is really got to do with investigations or experiments. And I'll talk a little bit more about that. But when you explain that, of course, we'll start with the light blue first. When you observe something, when you are posing a question, when you're conducting investigation, when you're describing or doing all those things, you're analyzing, all those are parts of a larger investigation. Step one is you identify, you pose the problem, you make a hypothesis, you plan your investigation and so on. And all those things are included in the steps. As well, we're talking about explaining at the end of an investigation, that's where you do your conclusion and discussion. So things about explaining can also be done. So all of those could be hit if you organize, and I think Chris will show you a lot of examples, organize a lot of the stuff around those investigations and experiments and have kids discover a lot of things. And so investigation can, even though it looks like a lot of separate ones, I'll group them together and say, we're going to be doing a lot of investigations in this organizing unit. If you flip down just a little bit further, Chris, right, you'll see that there's the light gray ones that I've highlighted there. When you look at those are all really part of another sort of larger skill, and that's really this designing something. And I'll show you in a bit, the grade 4 computer science learning outcome lays out what design is. You make a plan, you do this, you create, and how you create a product or an artifact. And I'll show you where that's located. But in a sense, that's what is really involved with all those, is really following the process of design. If we go on to the next learning outcome, Chris, just that one's a really quick one. It's just scroll down to the bottom and to the second page. Here we see comparing and contrasting becomes an important skill. We'll talk about that. And then there's that explaining again, explaining relationships in weather pattern. That could be an investigation. But when you take a look at all those, the pink ones there, really, that's an investigation as well. We can handle it as that, but that would be a descriptive one where we may be doing some research and watching some videos and doing some things, not conducting experiments necessarily, to do the things that are required there. So that can all be also organized around investigations. And that's what I'd like to share with you next is that little bit on investigations. So we can just get back to the main slide deck, Chris, and you're going to have to press another link. I'm sorry.
Yeah, which one do you want?
Go to the investigate, because there are 4 different types of investigations: the descriptive, comparative, experimental, and so on. And they're all part of what we can do in grade 5. So we can investigate, and I'm going to step back to find out the process of investigating. We have to take a look at grade 2. That's the only place where you're going to find that. There is some in grade 1, but it's not as detailed in grade 2. So as in grade 5, we got to step back to the grade 2 and take a look. Oh, when you investigate, what does that mean? And there are the 7 steps listed there, the scientific procedure. In grade 1, they do talk a little bit more about observation. So it might be something you want to look at, about recording data. Grade 2 introduces the whole nature of objectivity into the organizing or into the research as well. And then grade 2 lays out an investigation. Grade 3 focuses on 3 types of investigations: descriptive, comparative, and experimental, and what that means. Grade 4 adds on another layer about 2 types of data, the qualitative, quantitative, and whether that valid, how do we make sure our investigation is reliable and valid. And so all that stuff comes forward, when we're talking about transfer, all that stuff comes forward to grade 5. And grade 5 introduces the idea of a controlled experiment, biases, and variables. So whether that, I don't think that can all fit into this one organizing idea, because those are things that have to be taught along the way. Just want to point it out to you that way. For grade 5, there's a lot that you could work with. The important thing is the scientific procedure there. from grade 2. And if you want to include those other things, you can. And but because you're just piloting one unit, it's going to be hard to include all those things on. So that's where you can find all that stuff when it comes to investigation. And that slide's going to be available for you as well, that whole document. Thanks, Chris. No, so then, so when you're looking for never, we'll keep on going. When it comes to design, I just have a shot there from the grade 4 curriculum. If you take a look at the knowledge column in the grade 4, that's the process of design that you can follow. And we know that design is not only used in computer science to create coding, but it's also used to make models, blueprints, prototypes, objects, and so on. And so if you're getting kids to design, that may be a process you may want to have them follow. Next slide, please. So really quickly, here's where we are. All three of these things do transfer the specific or the individual concepts from the knowledge, the general statements from the understanding column, and the skills move forward as well. So the question is now that we know that those are the things that transfer, how do we actually have that happen? How can we support that process of transfer? That's where we look at Hattie next slide, Fisher and Fry, and those 3 stages of learning: surface, deep, and transfer. Surface is where we really learn some of those skills. So before we get kids to investigate, we want to sort of teach them some of the basics of investigation and maybe some of the related concepts with investigation, like analyzing and so on. It can be done through mini investigations, but you don't want to do a big one that they're going to be responsible for sort of gaining some understanding through the course without some of that practice. So that's where they develop those individual skills and concepts, not just the definition, but can they find examples of that? Can they demonstrate what lift means, not just knowing what the examples? Can they demonstrate thrust and those kinds of things? So that's at the surface level. Okay. The deep levels, when we take those 3 or 4 concepts together and put them together, and those are the understanding statements that we've taken a look at. Like, how do we get kids to form those understandings? But how do we also get them to examine a situation or a context through the lens of that understanding? And we do that by guiding them through the deep process, and we feel they're ready. We send them off on their transfer process, on their transfer activity, where they take their skills and understandings and apply them to a whole new or novel and unfamiliar context. And the key there is that they're doing it with independence within a unfamiliar context. Next slide. When it comes to the surface learning, there's a lot of activities and instructional approaches you can use. I have a pile listed there, but I would like to maybe just draw your attention to one, because not only the individual concepts or things that we teach at the surface level, but there's also the individual skills. And you can see at the bottom, I have the direct teaching of thinking skills strategy. This is where you may want to introduce those skills at that level. You can maybe click on comparing and contrasting, Chris, because that's one of the skills that's used in this at the very, I'm just going to have you just a quick run through of how to read this kind of a document. On the left is what the teachers do at the surface level. So teachers get ready to do this stuff. And the right is an example of what that might look like. So if it's comparing and contrasting, you want to make sure to define the skill and any related concept. And comparison and contrast are 2 concepts with it. So we're looking for something that is similar and something that is a difference. Then the next key thing is to define the steps. What is involved with the comparing and contrasting? Well, there's 5 steps that I have there. You'll see that, and you can scroll down. When I have the steps done, and I say, well, I look at it carefully through the lens of concepts, and what are some of the key concepts in those steps that kids need to understand? For example, you can't compare without criteria. You need something. It could be the properties of something. It could be the ways of movement of something. If you're going to compare movement, or if you're going to compare the way they look, you're going to use a certain set of criteria. And so they need to understand that. And there are some, I don't have them linked there. How come? Boy, oh boy. I thought I had all the, oh, I see. That's why we're on sub-skills. That's okay. If you could scroll up just a little bit, Chris. Okay. Right. So you see some of the key, oh, it's not going to do that for you. That's okay. But there's some examples of what you could click on for what an analysis is if you're not too sure, just to give you some things to move forward with if you want to help your kids understand what those things are before you go in and do those things like a compare and contrast. So there's a very similar thing. If you just scroll down one more little bit, Chris, I'm sorry.
No, all good.
You'll see that there are, again, some associated skills. So for example, we know when at the end of the day, when we're done an investigation, in this case, you could use this for one of those comparative investigations, then you have to either share your understandings or represent it in some way. So there's multiple ways you could talk about your kids about representing, whether it be a Venn diagram, it could be a chart, it could be coming up and talking in class about it. It could be a variety of ways to present it. It could be a diagram. When it comes to deepening it, try to get the skills to use it in other courses, in other context, because they're not going to get good at the skill just by using it one time for one investigation. So where else can kids use that skill? If you back up just a little bit, Chris, to those orange statements, right? Embedded in there, in those skills, like I said, are other sub skills. Where else can kids do analyzing? Where else can kids do, where else is criteria an important thing? When they evaluate something, they need criteria. The criteria becomes a really important concept when you look at all the different skills that show up. So all the, if you can go back to the main slide, Chris. So if you take a look again at the surface level about introducing all those skills, I have 3 of them introduced there: observing, analyzing, investigating, experimenting, and comparing, contrasting. They're all kind of in that same way that break things down to steps. So you may want to use at the surface level to introduce the skill and get kids working at it. Next slide. When it comes to the deep learning, that's where we start getting kids to work with this understanding and those connections. Okay, and again, we can't just do it in isolation. It's not a statement to remember. It's getting them doing something with that understanding to demonstrate their understanding of it. And I'll show you what I mean in the next step or the next slide. We can do that through several things. We can get them to do things like concept maps, flow charts, that hexagonal thinking, and experiments, case studies, and photos and videos are all good things to use to really develop that understanding. But as you're going through those experiments and case studies and photos and so on, asking those conceptual questions, for example, how is this all related? Or how is this relationship of these ideas, how is that evident in this case study? So it's coming back to help them test their understanding and seeing it in different contexts. The whole notion of asking conceptual questions shows up on the next slide. They're just where you just give kids a sentence stem. How is this connected to this? Does this show this? It's building that relationship because their understanding deepens when they can connect different concepts to other different concepts. If you take a look at the very bottom, I have one that would be taken from, no, I don't. That's the wrong one. We can go to the next slide. We can turn our understandings into questions. And if we do that, then that becomes the nature of investigations. We know investigations begin with questions. So if we take our understandings, put them into questions, we can do an investigation where they're experimental, comparative, descriptive, or so on. So in this particular case, I took the understanding that, I don't know why I forget the blue top part, I'll have to get that, but the understanding at grade 4 is how our buoyancy and density are related. So take that and turn into the question, how are buoyancy and density related? And that becomes the problem to your investigation. So we go to the next slide. You could see it there, the understanding buoyancy is how is our buoyancy and density related. Before we do that, we have to make sure they understand certain terms. I have a lot highlighted red because I think the things in the red there are really the understanding that they're trying to get at. So I would do that a little bit later, but I would make sure that they understand density, mass, volume. They're all in grade 5 matter though. They're not defined in this knowledge thing. You could see this, the knowledge statement. Objects with the same volume, but a different mass will displace the same amount of water. So those definitions are found in grade 5 matter. Displacement, there's a bit of a definition there. You might have to work with that. We want to make sure kids know what those are before we get them to explain the relationship between buoyancy and density, because they have to know what all those are. And then when they do know those individual concepts, then if I'm going to have them to explain the relationship, as I mentioned, I'm going to have them see if they conclude that from some experiments. So I have some sample experiments that you can do there. You don't have to go there, Chris, but then in a sample template that you may want to work with that has all those sort of steps of the investigation all the way through. We want to make sure they got the knowledge pieces and that they understand what you're not just going to give them the sheet on an investigation with all the steps on it without practicing that first. So at the surface level, they're going to want to practice an investigation first. Then at a surface level, they know what those things are. Now we can give them this experiment to work on and this investigation to work on. And hopefully their conclusion becomes that. You could take those same things that show up in that understanding and say that if you take a look at that understanding, all these concepts are in that understanding. So you can say, to show me again, here we just did that experiment. If experiment, can you please put these into some logical order? And it might look like this in the next slide. Right. An object in fluid, if it's less dense, then buoyancy, which is an upwards force, will create a floating behavior. Right. The fluid, if the object is in a fluid has more density, then the weight and its downward force will create a sinking behavior in the object, which is really the connection that we're trying to make in that understanding. Next slide, please, Chris. So if you can get kids do that, if they've never done concept maps before, boy, oh boy, then start small, don't do that. But once again, you can deepen their understanding by, again, like as the diagram or what we just talked about earlier, give different contexts. And the understanding that we were looking at is anything that is less dense than the fluid in which it is placed will be buoyant. So we can ask the question, how come the chair is standing there on the floor, but the balloon is floating? The second one, the hot air balloon, is a little bit trickier because obviously it is buoyant for some reason, but it's a little bit different. We're talking about matter and the expansion of air and so on. But that might be one where we can get into transfer, perhaps, is a really deeper one. But you can see how giving different contexts and have kids explain their understanding will help them to really deepen that understanding. And finally, we can move on. Then there's the transfer pieces. In this particular case, we can take a look at some of the skills and procedures outcomes where they're constructing devices. Now they're taking their understanding of the individual concepts, the understandings, and if they've gone through the process of designing before and they know how to plan and create something, now they can construct a device that demonstrate those things. And now we're in transfer mode when we start doing that, because now they're applying their understandings and skills here. And there's other things that have been done there at transfer level. So to help to make sure kids are ready to move from surface to deep to transfer, it's that constant formative understanding. Do the pre-assessments first, especially with this unit. As Chris mentioned, there's a lot of things from the different grades that come into play. So find out what they know. If they're missing some of those ideas, then we spend some time instructing and then assess and instructing and assessing and so on, as we typically do normally. The next slide just shows you some things that you may want to consider when you're assessing at the different levels to decide whether children are ready to move or students are ready to move from surface to deep. We can use that surface level component and so on. Are they ready to go from deep to transfer? Then we can look at assessments that reflect the middle column. And if they're transfer, then the type of assessment we want to do to see them at that summative point or that transfer point, those are the kind of the characteristics that that your assessment or that transfer activity might have at that spot there. So, and I think that brings me to the end of my part. So now that it's kind of built that framework, Chris has got all those wonderful resources, wonderful activities that you can plug into place here. So Chris, take it away.
No worries. Anybody have any questions of Ted first before we move on? Because they are tightly linked together. I mean, Ted does such a fantastic job of kind of framing it for you as to kind of where we need to look at surface and what are those key concepts. And I'm going to just get out of this one first. And I'll get into that one. So I will link this one into TED so you'll have access to it. But again, this is just one idea, a way that you might consider. If nothing else, it might give you some resources. It's kind of impossible to give you all lesson plans. But I guess my preface for this whole unit is I'm not the kind of person, I'm not a teacher that's a stand up and deliver. I never have been. But I also would guard against this particular unit, the way it's designed. There's a ton of terminology in this. And it could turn into just being a definition, a definition, a definition, a definition, which is not exactly the most exciting thing in the world. And so in my world, I guess if I was, and that's what I'm going to share with you, is a way that you might consider it. I tend to go things like that, where we have lots of terms that they need to really invest in, that they learn them as they go. So let's just throw out some ideas at them. And as they're unpacking those ideas, and the terminology becomes part of that conversation, then we bring it in as a teachable moment at that point. So it just becomes a little bit more applicable. So now I'm going to test your brains, all three of you. I'll let you read that. Anybody know who said that? And some of you might not be old enough to know. I never forgot it as a kid. So the kids might find that kind of humorous, but there used to be a show on television in the 60s called The Flying Nun, and she had very little weight and she had this crazy habit on, and her line was always, when lift plus thrust is greater than load plus drag, I can fly. And that was the whole story behind it. But it was exactly that line that I don't think anybody in that generation would have ever forgotten how this actually works to fly, because that's how they always described it in the movie. And so every time she would do something and she would just take off when there was a wind, people would laugh and say, well, how can you can fly? And she'd say, this is what happens. So anyway, when I saw the definition and kind of framed them in the curriculum, that was the very first thing that came to mind. So I thought, I'm going to throw that in there. So anyway, they can have a little bit of a 2-minute visual of the Flying Nun show, because they do have something on there. So flying, floating, and energy sources is kind of the way I would kind of put these pieces together. And I'm actually going to start with the energy side first, before I actually start with the forces side. And I think of it in terms of, in the end goal, I always try to figure out what are the students going to do for me, to show me that they've actually got the concepts that I want them to understand here, and that they can actually transfer them. So in my world, I would like them to be able to combine both of these two columns and perhaps design something that would make their world more energy efficient, green, safe, whatever you want to call it, and however they want to frame it. So it could be as simple as, and you'll see I've got a bunch of questions, can you make a car that doesn't need fuel? So it's safer, it's healthier for the world. We don't have to worry about non-renewable resources. Can I make a plane that could fly from point A to point B and doesn't have to use fuel? What would it look like? So if I understand all the different sources of energy that I have available to me, which one of those might I use, or combinations thereof, that might help me make something that could fly, or that could go on water, or whatever the case may be. So again, it's their interest level. And so I didn't actually do it in the order that the outcomes, and you're not required to anyway in your curriculum. It's whatever works for you. And in this case, I would rather them learn about this and really get a good grip on it and find what they're really keenly interested in, so that I can leverage that for something that they might design at the end. So just to start off with, just provided sort of what are some energies that we use every day, and just getting them to just spout them off. Like, where do we use energy? We turn lights on in our house. We have our computer on right now. I have my iPhone, like whatever, any places that they can think of, and just making a list of all of those, even on poster paper or on the board, so that you can keep coming back to those. And as they made their list, how do we kind of divide those up into what the sources of energy are for those? So as we start to unpack, we can start to divide those up a little bit and say, hey, you made me this list and where would you think that would fit? And where we think this would fit? So the video that I have here for you is really just an overview. It gives you a really good intro of what are all the sort of renewable energy possibilities that are on Earth right now. But it doesn't get into them super deep. And that's what I was looking for, because I would like them to say, watch this, for example, and then I'm going to ask them at some point, which one was really interesting to you? I want them to learn about all of them, but I know, and in my world too, there would be some that would speak to me more than others would. And so from that perspective, want them just to get an overview. I'll go into that one. And then how am I going to unpack this renewable energy? So I would probably do this as a case study. And in a case study, even that video could be a great opener for my case study without me telling you specifically about every one of them. And they could choose maybe 2 or 3 that resonated with them, or there's a book called Energy by Joe Windsor, and it might be in your school already. It's a sales series from Pearson, and those are very popular in the schools. They've been in there for a while. You might have that one, or you might want to show them a different video, and then I have some follow-up books. So in the case study, I would basically just get them started, give them an overview of those sort of ones that are listed in our curriculum, and then there's a couple more in the video that I've actually included in there. And then we ask them, which one really resonates with you, and how would we invest in that? What would you see us doing in the world to really bring that forward? So if it's going to be wind power, how are we going to use that wind power? How do we harvest it? Where do you live, right? What community do you live in? Is it reasonable to even talk about a wind turbine in your area if you're not in a windy area, right? If you're living in the province right now and you're down in Brooks, like have at her, like that's your world down there. It's nothing but wind. So I get you're going to have to really think about, and they should think about, if I was going to try and invest in renewable energy for my community that I live in, what should I be thinking about? Because what's available to us? So there is a book. This is the Energy book by Joe Windsor. Here's the table of contents. And so when I say reading this, again, this is just an overview. It wouldn't give me enough deep dives into any one of these. But as I read them through and I look at some of the diagrams that are in the book, I might find something that really kind of speaks to me. So one of the pieces that starts off with is just, and this is why I say it's just an overview. We got the sun, we got the wind, we got water, and then just unpacks in a graphic organizer sort of a half a page on each one. So no deep dive. But again, for some students, this one might be enough for them to say, I don't even know what a wind harvest would be, or we have one of those on our farm if you're in a farming community, right? And what did you use it for? And how could it be used if it's not being used anymore? So this is the name, or this is what the book cover looks like. It's from the Sales series. So have a look and see if you already have that in your schools or in your library. They're common. This isn't a new resource. These are some ones that I found from Scholastic, and I ordered these last year. But this would be my follow-up. Let's say that Ted says, I really want to go into wind power. Like, I think I could come up with some things in there. I really want to dive into that one. These could be small books that you have available to them where they now do some reading on their own, right? So let's go back and become the expert on wind power. I'm going to be working in a group. I'm going to come back. I'm going to share what I've learned based on the framework that you've provided for me, if that's how you're going to do it with a case study. Or geothermal energy, or in this case, solar power, water power. So what speaks to them? If you don't want to do this as an individual group, then these would be books that you could absolutely unpack as a case study, as a class, and simply use the information. And then you could actually chart it out to say, where are the similarities with these and where are the differences? They're great books. I was really impressed with them. The other one that we've been talking about, and if you go to the grade 4 one, you'll see that we talked a lot about the Max Axiom books. They're graphic organizers. These books have been around for a while too, since at least the early 2000s. They're all little graphic organizer books, but they are all specific to science. And the kids love them because they're designed this way. So this one just highlights, for example, what a non-renewable energy is. And again, I could just define all of this. I can just say coal, oil, and natural gas, or I could actually have them read some of this. and have them unpack some of those, again, depending on where you live. When I lived in Hinton, we had lots of coal mines. And so a lot of them were open pit coal mines. So we would take students out there so that they could actually see how all of this works. But then we could also have a conversation about reclamation of land and how do we reserve back the land so that animals still have a place to live and all of those pieces. So we could tie all kinds of conversations together at the same time. So this is one of those series that you might want to look for as well. They also have a teacher's guide that goes with it, but this one came from Renewable Energy. So again, if they are working on a case study, I've done a general overview with them. I provided you with some sources that you could share with individual groups, or if you're going to unpack them one at a time as a class, then you've got some here. But in this case, this is a general one about renewable energy, in this case, geographic, from the National Geographic, sorry, and it's general. It has all of them in here. This one is very specific to the wind turbines. So again, depending on where you live, some students may have never seen a wind turbine, like they have no idea what that's all about. So again, that's a new one for them to have. This one here, I'm just going to click this one on. This one does come from the US, but I had gone through this before for another piece of information I was looking for in a different course. This is based on the NEED program that they have a project. So I'm not so concerned about the units and stuff that are in there, but what is very handy and what is very nicely done is they created for each of the groups of teachers a little bit of a handbook. And again, remember it's for the US, but the parts that we need has no bearing on where it's coming from. So if I just click on, let's say this one for grades 3 to 5, you're getting an info book. And the info book just, again, talks about in general terms, what are the different kinds of renewable energy? What's the history behind them? That's another piece that kids don't even know, how long some of these have been around for a while. And so again, it's just a resource that you can look at from different ages or students can use. It's not like you have to print this all off, and that would not be my suggestion. And then below that, we also have the Safety Smart Science area, the renewable. This one has a ton of information in it. So I'm trying to find places where you can go back and forth between renewable and non-renewable, but really a place for students that they can go to, that you're not sort of having to lead them into all the places. So you've got a lot of them here that you could
around the world renew
for these here. Not that I want you to think I forgot about Canada, because I didn't. So I went into the CAP area, and so the Canadian Association of Petroleum Producers, they do a great job of overviewing renewable energy for students as well. So this is a good site for them to go to. This gives them a little bit of an overview about the oil, about all the different uses, natural gas. So this is our Canadian side of it. And again, it just gives them a source point to discuss or think about some things that maybe the other sites don't, that we wanted to go into. And then when it comes to this, I had just put some thought-provoking. These also come from the Max graphic organizers, but they always have some little interesting tidbits at the end. This is only 3 of about 12. But just some points in there for either them to think about. Sometimes these prompt students to say, oh, I could actually do something with that. So that might be their project that they want to unpack, and just prompting their thinking. So for example, used vegetable oil from fast food restaurants doesn't have to go to waste. Why not? What could you do with it? And so some students might want to do a bit of a deeper dive into that to see how does that work to power vehicles? How do they use that? How does that become a renewable energy and something that I recycle? Because we did that already in matter where we talked about recycling. How do we tie all those pieces together? If we talk about flight, and I want to remind you that flight was in the grade 6 curriculum in our old, right? So you have tons of material there that you can access as well. It's also, though, I'm going to say very definition oriented, like it's here's a whole page of definitions, and that's really the kind of piece that I try to avoid. But you have lots of resources in there that you can use. Great diagrams. So I didn't bring that up again. I might be just bringing something like this up with students and just say, how many of you have ever been on a plane before? And then once you're in the plane, what did you have to do? I had to put my belt on. What did it look like? You know, get that descriptor. And then I might just say, how do you think that big monster took off? How come you got up in the air? Like what got you there to begin with, right? So just to get their thinking and how that works. There are tons and tons of videos that you can use that help you to understand the principles of the aerodynamics to lift the plane up. So, I mean, there's no shortage of those. But I'm not sure that I would just jump right in and say, did you know that some of these are opposites to one another? That's the piece that I would like them to unpack as we start to learn about how that plane got up in the air. So that thrust and drag are opposites to each other, lift and gravity or weight are the other opposites. But that's the pieces that they're going to learn. And the two links that I have down here will unpack. The first one unpacks this for them, and actually we can use that as a talking point. And then the second one, it gives you a bit of a simulator too, to see how do the wings on the plane help us to move up? How does the air against the force of the wings help us in order to get the nose of the plane up so that I can actually start flying and have liftoff? So those pieces are in there as well. And again, I would want them to understand there are 4 forces that are acting, and those 4 forces are going to make the difference between me taking off and not taking off. Those are the same 4 forces that are going to keep my boat floating or my object sinking. What are those forces? And in this case, we'd be using the word buoyancy, but I have those natural forces that exist, and I need them to understand what those are. So then the question would be, how do you get a 747 plane to fly? Right? That might be our opening question. How do we get that big monster to get off the ground? How do we launch a manned rocket ship? Like we took this thing and it's up in space for how long, but how did we get this big monster of metal to actually take off and keep going, right? They need to understand what are the differences and similarities between a 747 and a rocket ship. There are some for sure. Compare planes and rockets and their designs and liftoff. That will speak to some of your students instantly. That's an area that they love to get into. Some kids, that's not their interest, right? So a plane flies and a canoe floats. How are those concepts similar and different? How do we connect the pieces for them? So when I look at those, again, what's an overview of something that floats? What happens when I build a canoe? Or how do I put something that sits on water and it floats? How do I know that it's not going to sink? What are the pieces and the forces? So this is your general opener that helps you to just introduce what helps something to float. If you want some other pieces to this, grade 2 science in the old curriculum had buoyancy in it as well. And in that one, we also linked it strongly, and you could do the same thing here, to canoes that First Nations made and used as their mode of transportation. But they had a very specific design and a very specific way that they put them in the water. So there's another piece that we can make the connections for the First Peoples in there as well. And there's lots of materials on that.
Kids want to know. Have you ever taken...
Sorry. Okay, what about, I want to just test what floats and sinks. How do I make the connection between what substance, what's density, what mass, what object, what's the properties of it, what helps me, and what are your predictions? So when you test an item of what can go in the water, what could float, what doesn't, so this is just a quick test in here. And then my question is, what happens if I change the water to olive oil? Will that change something in my conclusions? Will it change what floats? Will it change what sinks? Will it change how it falls? Will it change what the gravity does? Again, those are just questions for the students to be able to investigate.
In this experiment, we will...
So, sort of to tie some of these together then, if I've been unpacking all of these and we maybe really did a deep dive into 2 or 3 areas, I want them now to show me that they can transfer that knowledge and take it somewhere else. So how do birds and kites fly using our science vocabulary? Explain to me what we've learned. What's the difference and similarities between a feathered friend and a big kite that you've got going out in a windy day, right? Or I put in brackets, if that doesn't resonate with them, what other 2 things could they compare, right? Just let them choose. I mean, they're more likely to do that. What about a hummingbird and a vulture? Why does a hummingbird move as quickly as it does? Why does a vulture? But they will fly. They both fly. How do they both fly? They're different, though. There are some similarities. There's also very big differences. How does a supertanker float? How does a barge float? If the whole thing is metal, and we say that metal sinks, how is it that a supertanker is floating? So, and it's full of oil to boot, right? So again, having them connect what they've just learned to buoyancy in order to answer that question. Using your knowledge of buoyancy, compare a speedboat and a water crawler, right? So you got these speedboats that just high speed skip over the top of the water. What about these little water crawlers that sit on the surface of the water? Right now I get into the weight of those. Don't give them enough to fall through, so they sit right on top of the surface of the water. Again, students might not even know what a water crawler is, so maybe they get a chance to have a look at that. Not everything that's on top of water is going to sink, right? Tying it together, could a car drive or a plane fly without fuel? You're looking into the future at renewable resources and a safer, healthier world to live in. Design a model that could be considered for the future well-being of mankind. We did something similar to this with our grade 4 students when I was in a school, and they designed their own little solar vehicles. They made them out of construction paper, but they used little solar cells and panels, and that's what they used to charge it up to see how far it would run down the hallway. Some of them used a battery, but the point was we wanted them to think about how would they design something that could be energy friendly in the future, right? So what options do they have? What could they do? Could they come up with a new kind of something that floats, a new kind of boat, or whatever the case may be? So this is really a place for them to start leveraging what their interests are and what maybe they see as a hookup. Another one might be looking around your community. What could you design in your community that might help to be a stronger point for renewable energy? What about questions like, now homes are being built, and you'll hear the ads on television say, with a minimum of 4 solar panels on your roof, right? That's a given now in the house. Even if you didn't want it, you're getting it. So why do I want that? And where should they put those solar panels? Like, that's another question. Where should you put it when you build a house? So maybe they make a small house or a model, and they put it in different locations and see how that affects things, right? That's another. They now make tiles that have solar energy panels built into the tiles of the house. So again, you know, is that something that we should do? Where does all that energy go when I get it? Like, where does that go? So there's lots of things that we can do here to tie this terminology, but I would guard against that it become just a definition, kind of an unpacking. There's so much in there for definitions, but that's better learned and better understood if we bring it into whatever order you're going to teach it in, but let them kind of uncover it. And so when I say, how did that plane get up there? It weighed a certain amount. We know about gravity. They learned that in grade 4. So if we talked about gravity there, then wow, you know, how come that thing's not falling out of the sky? So again, now we can get into the thrust and the drag conversation and how those fit in there, and the big turbines and the propellers, and the propellers and turbines in the plane have a specific angle to them, so they suck the air in to make the plane go up that way, right? Okay, so I don't know if that gave you some examples or some ideas or whatever, but I will try and build in a few more links before we post that, but that will be put up and you'll be able to access them and anything else that's in there. Are there any questions? Wow, Ted, we're getting better. It's 3 minutes to 5. We're not running over for a change for you guys. I'm pleased to say. Okay, so just a couple of other pieces that I want to share with you. We still have space that we're going to do, and that comes up, I believe, in April. We are going to redo these sessions again because we now know, obviously, that this isn't going to be a pilot year coming up now. It's the mandatory year for K-3. And so you will see these sessions advertised again. And so we've already been asked, you know, should I come to these again? And the answer is no, unless you only did one and you want to come, you're more than welcome to come again. That's not a problem. But what we're going to do is keep all of the videos and all the slide decks that we've already created with all of you. We're going to keep those in the folder, and you'll have access to them throughout all of next year. We're not going to take those down. But what we will do is we will add pieces in. So we're actually going to kind of create a bit of a folder. So in grade 5, for example, when you go into science grade 5, you just have everything in there called energy or living systems or whatever the organizing idea was. So when you go into energy, for example, at the beginning of next year, what you'll see is in energy, there'll be a folder called 22-23 school year. And then there'll be a new folder called 23-24 school year. Just so that for those of you who've been with us all the way through, you don't have to go through the list to see if there's something new that we posted. You can just look in the 23-24, and if there's something new in there, that'll be easier for you to find it. Then you don't have to go through everything under the sun. We do want to add some new things in, but we have to be cognizant that most of the people that are going to be joining us will be starting from scratch. So we can't just do additional pieces. That just won't work that way. We will redo the opening introductory video. That will be the one thing that gets replaced, just because we want to update it, maybe put in a little bit more like what you're seeing now at the beginning. And then we're not going to keep redoing that over and over and over every time we do a session, because we're just going to say everybody has to do it now. It's not optional. So we know that if you're coming to the whole thing, or you're choosing not to come to all of it, but you're having to teach all of it. So we don't have to review all of the front matter. So that's going to be happening. The other piece to let you know is that there is and you may already know, but in the K-3 right now, there is a document that has been prepared. It's called a curriculum support document, where we're unpacking sort of everything that has to do with math in K-3, putting illustrative examples in, sample assessment pieces. And it's been very well received. It's not quite finished yet for K-3s. Our target is to have that released by June 1st, but we are going to go ahead and start on a one for science. And this is not one that just the consortia have started. This has actually been started by school divisions, and we are helping to support that. And we had opened it up in the province to anybody who wanted to help with the K-3 math. And we do have quite a few of the school boards on that, individual teachers in some areas, lots of groups of teachers. So if that's something that you're interested in and you'd like to work on the science, just send Ted or I an email and we'll be glad to add you to the list. We're going to try and get that meeting going here fairly soon. We're going to meet with some of the big boards that are going to help us out with that first, and kind of just divide and conquer the work. The whole idea is to create something that all of you can use, but to make the workload easy, many hands. If you're teaching the course, then you're an expert in that field already. So that's an area where you can help out. Okay, any other questions? Everybody knows where to find your stuff and what folder it's going to be? We're good there. Okay. Well, thank you so much, ladies. Have a great planning day tomorrow. I hope that goes well for you. All right. And we will see you in April.
Have a good night. Thanks, Chris.
Gonna stop our